We are.
Is it Dr. Pan?
Yes. From, I'm not sure, it's Pan or Han.
And he's a PhD.
Yes.
Dawson's is here.
Yeah, he's just down the hall. He's an assistant professor here.
Assistant professor.
Intersection professor.
Teaches engineering.
I guess. Or computer science. Well, it says industrial engineering. So a little different.
Keep your hat and look at your
Yeah.
industrial engineering.
I don't think
Doesn't
he'll
work here.
probably need an electrical engineer for that.
Please, you
Or a technician. Food's here.
We have food.
Hopefully not a lot of people from Phoenix show up. In that part of the chapter. So far we've got 5 members. 4 of us is on their
Yeah.
Yeah, only 3 of them.
We had 9, let's say, I think.
They asked me to go
actually be here.
you on the floor, so.
Now I saw you put my name down next to Honeywell.
Well, I had them both right there and changed it after that. But
I'd like to call them and see if they can have a trouble more.
Joe who? Juarez, I think. Juarez. Okay. Oh, good. I hope I don't get him in trouble because I talked to
Missing sheets.
Okay.
I'll call them and see if they'll send it back out.
I said, hey, any chance you're going to meet me here? He goes, no, I got things to do. But I said, yeah, I saw that there was Honeywell reliability being presented. You know anything about that? He goes, no, I don't know anything about that. But if somebody shows up, I'll claim responsibility for it. I didn't know. I saw the title. It was under the standard stuff. Honeywell reliability. I'm not doing that. Who's doing it?
New career, Lou.
I used to work for Honeywell.
Oh, yeah?
So, I mean, I could talk about what I did in Honeywell 16 years ago. Yeah, it's 96 to 2000. So it's like back to the
Activity.
Go back here.
She's about 10 years cooler down in Tucson.
Yeah.
But
Yeah,
yeah,
between 5 and 10 orders.
yeah.
Number is 993.
I don't mind the heat, though. I like the heat.
Yeah.
You know, as long as it's not sticky, like you're saying, you know.
Yeah.
The saying they should have
Yeah.
had
Well, I live in Louisville.
Yeah.
It's kind of sticky.
They weren't charged for everything.
Yeah.
Yeah, we just went to see my sister over in Big Rockles.
Right.
Oh, yeah.
I don't know what happened.
Just drove out. That was a good drive. $12 on the road.
Here's the pizza, so
Okay.
enjoy it.
When I'm going to have a park large cheese, maybe they'll come back and do that. Alright, thanks. Do you think?
Known for his barbecue.
Lewis?
No, it's in Texas. Kirsch? No. Well, that was Kirsch was one of the places we went to. Black's was another one. Black's.
Are you texting?
So it's a place right next to the Broncos, and it's a little north of San Antonio. It was on the CBS News about being the best barbecue in the country. And they have this beef brisket that it just melts in the mouth, man. It's just amazing. And I thought it would be good if we mail ordered, so we ordered something to mail, but it was kind of like freeze dried, you know. Then you have to heat it up, and it wasn't the same. You know, a little chewy.
Yeah, I had some Boston clam chowder. Nice. Legal seafood.
Oh yeah, legal seafood.
That was good.
I ordered some for my brother-in-law online. It was pretty good, but it's not good as what you said it was.
Yeah.
something the same thing, but yeah, not quite the same. It'll be the first.
That probably takes like the rest of the animals up there. Yeah. Not get the army on and then now.
Yeah, all these spices that are getting fresh.
But you guys can go eat afterwards.
Sure, sure.
I'll grab a little bit. Macaroni, it's like a veg, maybe mushroom and thing. And all veggie.
Okay. Yeah, I was just gonna have a slice. I don't want to take too much. I don't know how many people show up. Hopefully we'll fill the place and pizzas will go quick. Yeah, Bob. Can we get your piece, Diane?
Don't get the mushroom.
Mushroom one? Is that the,
And we're gonna eat it all and then nobody's gonna have any snack. No.
how's things in Isaac?
It's going well.
Yeah.
Haven't heard any more rumors about sequestration this year so far.
Good. Yeah. Anything happening new with the Tees contract, Tees Sport?
They're trying this out a little less than that one.
Really?
They're kicking around whether we get to do our own or whether we have to go underneath some of the other contracts that already exist.
Good pizza place.
Oh, really?
Yeah, very good.
Very good. Hey, Jim. I was hoping you were going to make it.
Well, I was hoping too.
Good to see you.
Yeah.
Introduce him.
Oh.
Bob O'Donnell.
Huh?
He works for me at Raytheon.
How you doing? Hi, Jim
And
McLean.
he's our treasurer.
Oh, excellent.
He's still not official yet because they haven't got the checkbook, but we're working on it.
Yeah, well, as long as he's okay with IEEE.
Yeah, that's my
Yeah.
wife, Diane.
Diane, how are you?
Jim?
I don't think I missed you before.
No.
Came up to visit, okay.
And then Keith Moore.
Keith, yes.
He's our chair.
It's good to meet you, yes.
Well, it's a good experience, I think.
Yeah.
On campus before.
I did go around the block,
I did too, a couple times.
but I found the interest.
But I'm glad you're here and you moved from Minneapolis.
Yeah.
Hopefully you're enjoying the heat.
Oh, I am enjoying I've been looking forward to that for a few years.
Don't we all?
Good. Any seeds will do?
Yeah.
Yeah, absolutely.
Didn't realize you were having pizza. It's a good idea. Well, from the Twin Cities, found that the IEEE RSA we found it, right? It existed before, but when we started giving free pizza at the meetings, attendance went way up. And it stayed up. That was a big help.
Yeah, we have a sign-up sheet too, so please sign up around, sign up. Hello.
Howdy. Your speaker for the night, I think.
Oh, okay, you're from Honeywell?
Yeah, Honeywell.
Okay. Hey, Joe.
I'm Joe.
Lou Geller.
Lou?
Lou Geller?
Lou, go. Lou! Lou, of course. I know you.
You I recognize you.
Yeah, good. Wow, that's great. Yeah, I haven't seen you in years.
Yeah.
Where are you at
Are
now?
you in Deer Valley?
Yeah, I'm still in Deerville.
Okay. Okay, yeah, I was telling these guys I used to work for Honeywell for 12 years. Yeah.
Wow, I haven't seen you.
Yeah, I was talking to Dave DeRose last time.
Oh, yeah, is that right?
I was asking if
Hi,
he
how are you? What's your name? Keith. Hi,
He's our sheriff.
Okay, great. And you,
I can tell you whenever you're ready. You can-
sure, I'll just plug in. And let's see. There's, he mentioned, Ron mentioned there's Raytheon guys here.
Well,
You're now great.
yeah.
Oh, good. Okay, good. Yeah. I'll give you my card. You might have heard this talk already. Tony Raffanelli, who's
Oh, yeah, I know Tony.
yeah, you know, who's out there and he's out there and yeah, that's right. And anyway, he had me call into a group of, I guess it seemed like it was Raytheon guys from all over the country on this project. So I figured maybe somebody's heard this already, but but we can listen again. What's that?
Maybe we can listen again.
Yeah, that's right. Refresh your memory here. Okay,
Joe, you just copy your resignation to the desktop.
Well, this is
so, yeah, I just plug in my.
Be careful, don't close in the windows because we got a bunch of recording stuff going on.
Okay. Oh. Well, why don't we? Hey, there he is. Hi. Can I just plug in or?
Yeah, you can plug
Okay.
in.
I'll make sure we. Let me just leave it plugged in.
Oh, okay, I see.
Well,
Well, can
yeah.
you get your point, or is it like court going to RAM and all that?
I did that with my Twin Cities.
Oh, so you still can't manage it. Okay.
Yeah, they actually sent me a survey.
One right next to the mouse there also.
Okay.
Survey.
So Keith, might as well start with you.
Yeah, I'll see it here. Oh, maybe I'll plug in there. Yeah. A little busy over there.
Section, result of chapter. Right. Good. I thought maybe he was going to give us the benefits of this point.
There
He
we
gave
go.
it to his, no, his whole section, or whole chapter.
To fill out the form.
Yeah.
Very easy to do officers. Names, yeah, member, other officers. Attribute member. And any
We have been
meeting
meaning to join that.
Financial meetings, technical meetings or planning session. And then any other meetings, and any public meetings. Be careful not to hold joint meetings.
Now I have a reason. Now I have a real reason to join IEEE.
There you go.
I've been a member of ASME for a bunch of years. I'm in ASQ, but I figured, yeah, you know, it's time to join it.
We didn't do a joint meeting.
So I haven't seen you since I worked in meetings.
Yeah.
That
How
was,
long?
gosh, it was like 15 years ago.
15 years ago. I know it's been a while. Yeah.
I never forget it. I remember seeing him working.
Yeah, that's right. We
Is
did.
Joe Scalise still there?
Yes, he is. He and I work together all the time. So Joe's still there. And see, where can I sit?
When they get to December,
Sit right down.
the wipe out all 83
Yeah.
So humans be very clever
I
and
can't remember for the life of me what we
work
worked on
together.
together. I know we did.
Yeah, I do.
We always check on them.
Did we work with say Ron Ferraro?
Yeah, he was on boss.
He was our boss.
Yeah,
we
Yeah, he was a software guy, right?
No, he was the mechanical engineering guy.
Oh, he was mechanical? Okay. Remember Dan Elder?
Yeah, Dan, and then he retired, and then he took Ron took his place.
Oh, okay.
From Chicago, Jerry Lee took his when he left, and then he went to work for Raytheon in Santa Barbara. Working in Goleta.
Okay.
Yeah. Then we did a reorganization.
Gosh, that was one thing about Honeywell, man. We kept reorganizing like every year.
It didn't seem that way.
It was like every year, 86 and 78, with the new president came in, he was really bad, and he reorganized, and then the next year was when we had Allied Signal come in, so we reorganized for that. Then the next year was GE, right, so we reorganized for GE, and then that whole thing went away, and then we reorganized again. That's what, it was like every year was a new reorganization. Spruce.
But I used to work for actually your facility. I started at Hughes Missiles in Canova Park in 1975. And in 1975, we knew that they were going to move to Tucson. And so I don't know. It's the same, right? Isn't you guys the ones that came from Canova Park?
No.
Down in Tucson? No.
Yeah.
You're not Raytheon Tucson?
Well,
I'm
he's from
from
Texas.
TI.
He was
Oh,
from
you're
Louisville.
TI. Okay.
Yeah, we got like a combination of like
Yeah.
6 different companies.
Legacy companies, yeah.
Yeah, legacy companies. Like if you look at, I kind of studied how the organization is. We had 6 business units when I joined, and only 1/6, which is the Raytheon part that's in the Northeast in Massachusetts, represented the entire company. The rest of it was like, you know, the GMU stuff, and then it was the Texas Instruments stuff, the E-System stuff. Okay, what was that? The ITT guys in Fort Wayne. It was actually part of the government that we bought, a government facility that the government just said we're the best in ourselves. Yeah.
So you guys are is this the Arizona chapter of IEEE related?
Yeah.
Okay.
Yeah, exactly. We just started it. So it's our second meeting.
Yeah, try to get some of our guys, but, you know, especially,
Like Neil Bain.
yeah, you know, Neil and, yeah, but Neil would be a guy.
Yeah.
Then we got Anthony
Stevens. We have
Walter Grossman, of course, you know, and, let's see,
Like the list, if I run this in Arizona for
you know, Scott Bond have access
to see when it's updated, I know the list.
Got it.
Or somewhere there.
Stefanski.
There's Paul Stefanski and, let's see,
I will.
Steve Estrada.
Should have done this.
Aaron, yeah, Steve Estrada. He works. He's down there.
Not as much. Yeah, 5, maybe 5 degrees cooler.
That's
Not.
It's usually bigger than that.
So you're located where? Tucson. You're located.
Tucson.
Oh, you're on.
Yeah, so he's in Rita Road, and I'm more in the Palo Verde area.
No, I'm in the airport
Oh,
side.
you moved, you're in the airport side now? Okay.
And there's a student section.
I started off in the Rita Road side, then I went over to the airport side.
Say hi to the rest of the folks over here.
Working on Javelin, so.
Hi.
And we're, Javelin's split between Rita Road and the airport side.
But yes,
Yeah,
I'm like,
okay.
Yeah.
Well, that other thing.
Yeah, that other end.
The guy that I used to work with. And you're
Jim McClellan.
Joe.
I'm new here, just moved to Arizona.
Oh, you just.
I'm Twin Cities.
Oh, okay. I'm from Tennessee. And at least guys are the students, because he's a student in one of my classes.
You got a new comment.
Yeah, that's right. Today we finished. Today's the last day of classes, so.
hey, we
Hey,
got some
how you
more folks joining.
Can't seem to get out of here.
We got a sign-up sheet going around too.
Yeah, I'm filling out the sign.
Oh,
Oh,
you learned your whole life.
did I? Okay.
Learning.
Yeah, that's right.
Good.
You coming to apply for liability?
No, the ARS.
I'll do
No, I
that.
can't.
Okay.
Too much going on, dude. I already got a trip. I'm going to the MS. What is it called? The NSMMS.
Hey, Joe.
It's yours.
Hey, how are you?
It's the national.
You guys can't seem to get out of here. It looks like your thumb drive's ready to copy over now.
Okay.
Oh, take that one. I'm gonna pull the files off or something. Sure. All right. No problem.
I'll be there for a week in Tucson.
Okay. Oh, good. Yeah, be at the Ventana, which is
Yes.
where Rams will be too.
Yes, so it'll be there through.
Yeah. Yeah, nice place.
Now bring both over.
Good open area. It's got a very big foyer. That's like rotunda. So that's where we're with the Rams exhibitors.
Okay.
Hi.
Hello, sir, I'm Wayne.
Hey, Wayne. Hello.
Nice meeting you.
Nice to meet you. We have sign sheet going around somewhere? Right here. Everybody sign up? I also brought some Rams pens, so we're talking about the Rams conference.
Hey, what's
Feel free to.
Yeah.
That was in the year around 2012.
Rams pen.
Hey, all right, thanks.
Let's see what we got
Pens?
Highly reliable.
Rams? Yeah, for Rams.
Thank you.
And I get, that's good.
That's what reliability and maintainability or something.
Yeah, reliability, maintainability, supposedly.
Still going on. I haven't been to one in a long time.
No, Dave tells me he has a budget.
Oh, yeah?
Yeah, he
Well,
says he
he
has a
should.
budget to send people to conferences.
He's the director.
So look him up.
I definitely will.
We'll record this again.
Anybody else? Yep, definitely. Definitely.
Okay. Oh, there he is back. All right, folks, I think it's time to begin. A few minutes after. Brought Randy up. Randy's down in Sierra Vista. He's our secretary for the chapter, so he's going to be taking notes. So I'm going to send him copies of the slides, and he's watching via Google Hangouts tonight, and it's recording via Google Hangouts. It's going to go to our YouTube channel, and also we're recording via Camtasia, and it'll go up to the IEEE website. We'll upload it later. So everybody knows, I guess, since the last meeting, we had our first meeting in December. Hey, welcome. Come on in. There's a sign-in sheet there on the table for everybody, and there's pizza and drinks over here to the side. Just grab a seat wherever you can find one. Between December and now, we had a meeting with the region meeting, and they were selling these sound systems for half price, pretty much. They gave almost $200 for them each. And they were offering, yeah, go ahead. Careful where you trip there. So it's really meant for bigger audiences, bigger rooms than this, but I figured I'd set it up tonight, let everybody see how it works. And I actually tested the audio via the desktop here, the laptop, and then I hooked this up, and the audio is 10 times better with this. So I can see why they want us to use these if we're going to archive them and share them amongst all IEEE members. So when whoever's speaking up here, just get this, clip it on. It's already turned on. You can put this in your pocket, and then go ahead and done. I apologize. I don't have a wireless slide changer, so just use the mouse. So I'm going to. Randy, you have anything for the group before I take you minimize your window?
No, I have nothing today. Good evening, everyone.
Yep. Welcome. I'll sign you in because you can't do it from the sign-in sheet there.
Thank you.
Yep. All right, I'm going to minimize the video there. And actually I can leave it up for right now because I'm going to do a little bit more talking. Lou has brought pens from Rams, so if anybody wants to grab a pen, tell Lou thank you for the free pen. Yeah, take two if you want. I think everybody that was already on our email list should have got a copy of the minutes from Randy via email sometime last week or week before last. So I looked through them. I didn't see anything out of the line. Is there anybody who had anything that needed to be changed in the minutes? If not, good job, Randy. Awards. I got an email just, I guess, a few weeks ago from Loretta. She said that there's a chapter awards submission open right now for Reliability Society chapters, and they've got 4 places: first place, second place, third place, and fourth place. They all have a cash award with them. Fourth place is $200, and that's for anybody who enters at all. So we're definitely going to put an entry in. So we've got a very small budget here, pretty much enough to buy pizza and drinks in our meetings. That's about all we've got. I think we've got $400, maybe $300 in the account right now. If we do this, that'll give us $200 more, so we'll have enough for a few more pizza parties with our meetings. The $500 we had in there so far is from the Fort Huachuca section. Last year, when we got our charter, they donated $500 to the chapter. So I'll see about getting with the folks and putting the award in as the chair. The treasurer checkbook. Bob was our duly elected treasurer, and I gladly bequeath the responsibility of the checkbook and everything with it over to Bob. You're very welcome. I already spoke to Bob earlier when we first got into the meeting. He's not actually set up on the account yet. I got an email from IEEE folks just 3 hours ago when I was driving up here. So they've got to get some information on him so that they can get him set up. But as soon as I can do that, you can go ahead and keep the checks. I'll sign the check for the pizza and everything tonight, but you can have them and afterwards tonight. Already went over sound system. Officer elections recap. The officers, if you would, see, I got the list down here. Put my reports on V-Tools. Excuse me. It was unanimous votes. I was elected as the chair because I was volunteered to do it. I'm glad to do it. I'm happy that we had good turnout of all the voters. Vice chair is Lou.
The secretary is Randy Brito, who's on our video here. Treasurer is Bob O'Donnell. Membership and publicity is David DePiola. And newsletter is Haito Lau. Here he is. And webmaster, Lou's going to do double shift to do the webmastering for us. So congratulations to everybody. Thanks everybody for voting in the elections. We'll make sure that all, it says it's been recorded via vTools, but they didn't seem to have gotten it when the lady was wanting to give you access. So I'll double check and find out exactly why she has it. Maybe she just didn't have a chance to look. And that's all the administrative comments that I have. Before we get started with our presentations tonight, open the floor to any announcements from anyone before we get started?
I was wondering about the website. Is there somebody here from the section that I could talk to, for the Phoenix section, that knows how to get with the webmaster and figure out the access to web tools? Anybody from the Phoenix section? No?
I don't know.
Yeah, I've gone through what the IEEE told me is I got to get the webmaster for the Phoenix section to give me access. And I had the guy's name and then emailed him, and he said, "You have access." And I said, "I'm not getting in." I mean, I tried the login he told me, and I'm not getting in. So I'm hoping that person can be here, do it side by side, and say, "Okay, what do I got to do now? I'm doing this. It's wrong."
Okay. Well, I will try to follow up also and see if we can get some information on how we can get our website set up. It's definitely one of the tasks we need to do. Any other? Yeah, go ahead, Jim.
The Reliability Society sponsors about 10 different conferences around the world. Sponsors and co-sponsors. So probably include into all those if you don't know them already. They're sponsoring one of the ASQ in the fall, September 9th through the 11th in Boston. Called the Accelerated Stress Testing Reliability. They're just about to close the call for papers. I'm on the committee and they had a meeting this morning and said, "Yeah, we'll hold it open maybe another week or two." Boston will be a great place. That counts.
Yep.
When's it from?
September 9th through 11th. Oh, okay. They actually came here. Turner MIT. Set up a tour of MIT.
Okay.
As well.
All right. Thank you. Thank you, Jim. Any others before we begin? I think Lou is up first. So Lou, I'll pass the lapel mic to you. And then after that, Lou's going to go over reliability standards activities. And then after that, Joe is going to present to us about the reliability program at Honeywell. So the floor is yours, Lou, if you'd like. Thank you. I'll minimize him and open up your slideshow.
Let's see, is this on right now? Okay.
Sure.
Thank you. So I was just going to take 15 minutes to go through about 7 slides. I'm going to talk about the IEEE Reliability Society standards and which ones that we are managing right now and also developing. Okay. There we go. So these are the 5 standards that are being managed right now for sustainment. They were developed several years ago. You could see based on the numbers for each standard. 1332, for instance, 2012 is when it was last revised. 2010 for 1413. So each of these standards has gone through several revisions. For the first one, 1332, that was a standard that was developed in the 90s when MIL Standard 785 was canceled. The government came to Mike Peck, and he was representing the IEEE in different aspects, one of which was with the Reliability Society and also with other societies. But at that time, we weren't developing any standards. So they asked him, would you be willing to lead an IEEE reliability standard and start the process off? And so 1332 was basically created at that time in the 90s, and then we updated it again in 2012. And now it's led to these other standards that you see here. So 1413 is the prediction standard. So you start with the program standard, the 1332, and 1413 is for doing predictions, which is not to replace 217, even though that's what Mike Peck wanted to ultimately do. It was more of just set up a standard framework for how you would do a prediction, whether you're using your own data or manufacturer's data or handbook methods, which could include 217, but as well as some of the other standard prediction methods such as SR332 from Telcordia. And then 1413.1 was developed as a companion document as a handbook selection process. So if you are not sure how to go through picking the various types of handbooks that exist, 1413.1 was meant to be a guide to help you through that process and be more of a cookbook, where 1413 is really a standard that has maybe 10 pages. So it's kind of tough to shell out $200 for a 10-page document. A lot of people don't do it. I can tell you they're not very popular, but 1413.1 is about 200 pages, and that's about the same price, $200, and people are buying those.
Can you get it through IHS?
No, it's separate because IEEE is its own standards body, so you'd have to buy it through like IEEE Explorer, a database that they have. Now you could get maybe a subscription with IHS that allows you to also get IEEE standards. They might have a relationship there where they allow you to connect in through that. Like for Raytheon, we're corporate sponsors of IEEE, so anybody that logs in to a Raytheon website can go to what we call our research and library page, and from there you can get access to Explore, and you're basically logging in as an IEEE guest, a Raytheon guest, and you immediately get access to all the standards. But then me being also a member of the standards committee, so I can get in through my own login and get all the standards as well. Now for IEEE Reliability Society, I belong to that as well. The Reliability Society will let me get to my standards also, but only the reliability standards, which are these I'm showing you here. But because I'm also a member of the Standards Association, I can get every standard. And then, let's see, 1624. So 1624 was another companion standard, but this one is for the 1332. So 1332 is the program standard, and 1413 is a standard that tells you how to be capable of doing reliability. So it's kind of like a CMMI. It was modeled after CMMI concepts for reliability, for software. So just like you do a capability maturity model, integration for systems and software, and then say you've gone through a SCAMPI audit to verify that you can do level 5, let's say, which is the highest level for that CMMI, SCI, which is the Software Engineering Institute's certification. 1624 was meant to be similar to that. It's not an audit body. It doesn't sanction an audit body, but allows you to do an assessment on yourself and get to the same level 1 through 5 in terms of capability and maturity. And that, again, is related just to reliability for a system, which would include hardware and software. And 1633 is the software practice. So this is not a standard. It's a recommended practice for software reliability. And this tells you how to do software reliability engineering and also do predictions. So 1633 is going through a revision right now. It was originally released back in 2008, and now we're in an update mode, so we're planning to get that ready to go out to draft and balloting in 2017 is when we hope to get it published and balloted. Usually it takes about a year when a draft is released for ballot before it goes through all the reviews. But the plan right now is to have a draft that's internally worked within the working group this year. So 2015? So we're 2 years ahead with a draft, and I'm hoping that if the working group ballots it internally and says, hey, this is something we can show to other people, maybe it'll get out informally to other folks outside of the working group. And the working group's fairly large. It's about 100 people. So you can know somebody like myself that's in the working group and say, hey, when is this ready for other people outside the working group, and then I can make sure you're on my list to get a copy. And then it'll go formally through ballot. When it goes through ballot, you have to be a member of the Standards Association to be able to ballot it. So that's why it's not something you'd see directly. And then we have these two standards, which are brand new. So we have a PHM standard, Prognostics and Health Monitoring, or Health Management. In this case, PHM has two definitions. One is Prognostics and Health Management, which is what this standard is, and then there's also Prognostics and Health Monitoring. And we went through a big gyration in the beginning of creating the what we call the PAR, which is the Project Authorization Request, where some folks wanted to do just for monitoring. I just care about health monitoring, but some folks wanted to do a little bit higher level of management, not just monitoring sensor data, for instance, but also managing that data. And it would be like having a defect reporting system, but not doing full failure reporting analysis corrective action, which we call FRACAS. So FRACAS is more of that management piece, managing your failures to root cause, to closure with corrective action. And that's what this is intended to be, is tying in FRACAS type of management with the prognostics and health monitoring. Mm-hmm. Yes. Yeah. Actually, University of Maryland is the working group. So you can see there that working group is under Dr. Sony Matthews. He originally was with PEC. So PEC is the official working group chair, but he never attends the meetings. So I really give credit here to the people that are managing the meetings. So Matthews was one of PEC's graduate students. He's since moved on. He works for Halliburton, but he's still maintaining the role as the vice chair, if you will, even though PEC is, the chair, he's not attending. So I kind of look at Sony as the unofficial chair, and then Arvind, and that's a big long name which I cannot pronounce, but Arvind is what we refer to him. He has, he still works as a graduate student in University of Maryland, so he talks to PEC often, and some of the other professors like Das, Diganta Das, Mike Osterman, and others. And then the last one I'm going to talk about is the Reliability Growth Standard. This has been a standard that's been in the thought process, the concept phase, for many years. It started out as a IEEE standard 1467, and then because it started out with a lot of fanfare, like Larry Crow was involved. A lot of folks know Larry Crow as a developer of growth models beyond what Dwayne Groth had done. And he had lots of ideas, and this was very much a Larry Crow type of a standard. But then other people got involved, and it kind of shifted to be more inclusive of other methods. And so he kind of bowed out, and I'm trying to bring him back in now. So what we've done is said, okay, 1467 has been tabled, and in a way it's been canceled, even though it was never released. So the PAR was canceled. And so we never did develop a draft that I could share with anybody. But now what we've decided to do is form a partnership with the IEC. So there's a lot of documents that are out there today, and I'll talk about some of those in a minute, where we have these PSDOs, which is a partnership in standards development with IEEE and IEC, ANSI, ISO, those standards bodies. And so this is the first time that we've done that between a reliability society standard and an IEC group. And this is TC56.
For IEEE and IEC, they cut and paste each other. Normally when the IEC document the same as the IEEE document.
It will be. The idea is that 61014 is an existing document that they wanted to revise. And so now when they're going through their internal working group to change it, they have to share it with us and let us contribute with comments and changes. And so that's where we are. We've gone through several rounds now of seeing the draft that they've revised. We provide comments, and they're still going through the changes. They just had a meeting with their group during the RAMS conference in Florida in January. So we haven't seen the results of that new revision.
So what happens? IEEE will sell the
well, either one.
IEC will sell.
You can get it through IEEE or through IEC. They both sell the standards.
I guess when the standard is called out, I guess you can call it.
Either one, exactly. Yep. So I said I was going to talk about the cooperation we have with other groups. So we're collaborating with the IEEE Computer Society. That's who the CS is, and they have various standards organizations, standards committees within the Computer Society. So I'm just a committee of one within this society within IEEE, but the Computer Society has probably 10 committees that deal with different types of standards. And so this is the S2 ESC, which stands for the Systems, Software, Engineering Standards Committee. And so they are dealing with these types of 15288, which is for systems, lifecycle processes, and 12207 is for software lifecycle processes. And these are used as a launch pad for all these different other standards. So for instance, to give you an idea, the internet, right? Does everybody know what the internet standard is? It's an IEEE standard. So 802, right? So 802 started out is where they defined what's the internet. Ethernet, exactly, and exactly. So now you know you got wireless, right? So what is that? 802.11. So that means there's a .1, .2, .3, .4, up to 11, and it's even going past that now. We use in wireless sensing with the Internet of Things, we use 802.15.4. So imagine that now. You got .1, .2, .3, and then they got .15, and then they have to have derivatives off of that, so now you got a 15.4, .1, .2, .3, .4, right? And then within .11, you got A, B, C, D, E, F, G, right? For the different frequencies and the power and the types of data that you're sharing over the wireless. So that's similar to what's happening here is they have this various parent standards, and then they develop these offshoots from that parent standard. So these guys within the Computer Society S2 ESC, they call it SESIX, and it's kind of, a lot of times people see it. My brother, I sent him a thing, hey, you should see what SESIX is doing. He says, hey, you can't say that on the internet. He thought I was saying sex or something like that. No, that's not what I'm saying. But it's like 40 standards just related to this one committee that they're managing, and now they're developing another 10 standards. And then if you look at the other committees within the Computer Society, they're developing 10 or more standards. You know, the communications, where the IEEE 802 lives, they have hundreds of standards. So it's quite a big organization for managing documents and standards. And when I talk about standards, it's not just a standard that has a lot of normative language, a lot of shalls and requirement type language. It's also informative. And so you could have a standard that's not a standard. In other words, a standard that's not normative, and that would be like what I talked about with the recommended practice. So that would be the far left of being a standard, but we still call them standards, but they're non-normative. It's more informative, right? Just for information purposes, you can't cite it as a requirements document. And then in the middle, we have guidelines. So there's, a standard, real standard, a guideline, and a recommended practice are the three types of documents that IEEE SA Standards Association calls as standards. A little confusing, but oh, and I put a number here. So I said 40 they were maintaining, and now they're up to 97. So that's the latest number, and I still haven't gotten in my head. So I'm glad I put it up there to remind myself and to tell folks that it's growing. So they're developing lots of new standards. And so we're also working with the IEEE S2 ESC to ballot standards that are coming from the IEC. So they're the ones that showed me how to work together with the IEC. And if we have a standard that's similar that we're thinking of creating, and an IEC document already exists, or they're thinking of creating it, they're telling us we need to collaborate, right? We don't need more standards in this world. We need less standards. So if we're out there looking at, hey, this standard for reliability growth, right, 61014 exists. Why would we create a 1467 if they got one? Let's work and collaborate and develop one standard together. And then there might be cases where there's 3 or 4 standards that exist. Let's say SAE's got a standard, and IAIA has got a, or AIAA has a standard. Various ASME, all these standards generating bodies have standards, and if we can collaborate, the IEEE is very much interested in creating less standards and working together with these other organizations. So these are some that I just personally voted on that have nothing to do with the reliability standards, just to give folks an idea of different other documentation that exists when you belong as a member of the IEEE Standards Association. You get access to every standard out there, and you can search through the realm of standards and be able to vote and ballot them and comment on them and contribute to them equally.
And was there a single systems engineering standard like EIA 632 or something?
So I would say INCOSE has been big in that area. They're the ones that really have what's a systems engineering standard, but the 15288 is the closest that IEEE. 15288. Yeah, this one right here. So 15288, systems and software engineering with system lifecycle processes, is probably the closest to the NCOSE standards. And by the way, NCOSE sits on the board with the S2 ESC. So they have a management board just like we have XCOMs and ADCOMs. They are on the XCOM. And then,
For a while.
oh, were you?
Yeah. We put the conference on in 1999. You got that one?
Uh-huh, I'm sure, yeah. I can't really remember, but I'm sure I was. Yeah, I used to work with the NCOSE back in the day. Yeah.
Wonder where they're at.
Yeah. Yeah, you work with ABSI because they're developing some standards.
Yeah.
That's one of those. You have
Actually,
to,
this is what we presented to you.
okay, cool. Well, good segue because I'm done. This is just the links, and I'll hand off the reins to you. Yep. Thank you. Yo, Joe. I'll set you up.
Give yourself 5 minutes while I'm going to send the slides.
5 minute break,
Randy. Quick refill on pizza and soda if you like. I'm going to send these to Randy so that he's got them. That way, and then we'll continue on.
Yeah, let me quit. Had to wear my special speech shirt. Okay. Actually, is it on or?
Yeah.
Can you hear me? Can you hear me? Oh, no.
Yes. Randy, can you confirm you hear us?
I didn't turn it off.
Okay, so I'll just put it in here.
No, PHM, we're having the management, PHM part of it, so it's like brackets. No, brackets is still.
Yeah.
Yeah, just like you do,
What's that? Yeah, there's ASME, yeah, those two. Yeah, those two, yeah. We're gonna put both, we're gonna pull both of them, actually open both of them. Might as well, and then I can, one of them is a piece of the other one. One of them is the background to the other one.
No, it's not, nobody's
Yeah.
taking a standard for IEEE just
I'm debating whether I should have a piece of pizza since my wife said, okay, now you're coming, we're gonna do a dinner thing. I guess I can always fit in a piece, right? Oh. Here we go. All right, so I guess I don't need any introduction, do I?
I guess you make some old friends here.
Yeah.
Okay. When you finish, can you just give me like maybe 5 or 10 minutes?
Oh yeah, no problem. You're both open? Okay, yeah, we'll start with this one and then we're still in the break, right? I'm going to try to finish my pizza. I don't want to choke on it. How much time do I have?
Oh, we've got until 8 o'clock at least.
What time is it?
That's 6:30, 6:45.
All right. Well, I'll make sure it's 20 minutes. I'll do a, try to fit it in 20 minutes or, well, okay, I might go long, but a little longer. We'll see how it goes.
So long, depending on how much time he takes, you can, if you'd like, you can present some on your programs.
Yeah.
How much time we have left?
Want to do that?
I guess once 10 minutes.
Yeah, I won't take. I mean, who knows? People might have lots of questions. I guess it's not like we're at a conference here and I got to give it in 20 minutes. And then they put the hook, you know.
Yeah.
Yeah, you mentioned there's a conference in Boston because I went to MIT and my son's at Harvard, so of course
I asked you when it was because I mean I'm always finding excuses to get out there and see them. So this might work out.
Just Google ASTR, and you'll get accelerated stress testing reliability.
Mhm.
We'll get the Art Society, so on and so forth.
Oh, I see what you're saying. Right.
ASTR, IEEE ASTR.
Mhm. So you're still accepting abstracts? Is that where we're?
Yes.
That's where.
Another week.
No, good. Okay. No, check it out.
26 ones, 2.5 days.
Good to know. That'll give me an excuse also to go visit Raytheon there in Boston.
We're going to be in Cambridge.
Mhm.
Hotel. I'm not involved with that, just doing the registration.
Yeah. No, man, I know. Where is it there at the Marriott? There on Kendall Square? I don't know. No.
Nice hotel, Cambridge.
Yeah. It's probably one of those there by MIT. I'll make sure to. Good excuse.
Good practice. Nice small town.
Well, great time of the year, right?
It is. We got it last year. Second weekend of September in St. Paul. I was the host for that one.
Okay. Cool.
Great time, right down the river, in Mississippi.
Yeah.
Weather
Wonderful.
operated, didn't stop.
Yeah, we were there in Boston when they hit that record 108 back. My son was on spring break, so we flew out there, and it was like, wow,
Never gets that.
it's amazing.
Wasn't
Wasn't
it?
it? Yeah, I got there for that when they hit 108 inches. I guess that was on St. Patrick's Day or something. I'm trying to remember exactly. But I think that was the day. So that was fun.
Every week, snow again.
That's right. Yeah. Well, maybe I'll. I had my piece. Maybe it's time to. Oh, you're handling membership too? Okay, good. All right. Let's see. All right, well, I'm going to give you my card. Maybe you can send me some stuff because in the heat of battle, of course, I'll forget everything as usual. Thanks. Okay, ASQ. That's right. Okay, so you're an ASQ guy too. Okay, I'm a member of ASQ. So is it under the auspices of ASQ or is it IEEE? Oh, it is. It joined IEEE and ASQ. Oh, really? Oh, great. Oh, I like that. Oh, fantastic. Geez, that's even better, right? And I'm trying. I always got to find a lot of synergies for doing things. I guess everyone can hear me. I think I hear the echo or something. Anyway, I'm Joe, and I work for Honeywell. And actually, I'm going to talk about some of the research I do at Honeywell as opposed to the Honeywell reliability stuff. So, and we have a program that we call the In-Service Reliability Project for lead-free. And actually, I gave this talk. So that's what we're using here a couple of weeks ago in Genoa, Italy. And yeah, it was great. Of course it was great, yeah. Yeah, and so anyway, yeah, and we have there's an organization which, I think for you guys, Tony Raffinelli is one of the members. Actually, Dave Pinsky was the one that went from Raytheon. But there's a group called the PERM, and you can see up there. Actually, I don't know. I guess we don't have a laser pointer, but anyway, up there there's an international group called the Lead-Free Electronics Risk Management Council. And currently, it's under the auspices of IPC. So for those of you who are, use IPC standards, you should be familiar with IPC. And we actually have been under the auspices of AIA, and then we developed standards also, but through their SAE standards, and we're developing a number of them for lead-free. Well, anyway, we have 4 meetings a year, and one of them is always in some great place in Europe. And so this one was a couple weeks ago. Now, the great thing about being invited to do this talk is that I'll be in Toronto in a couple of weeks giving a paper on this topic. And so so this weekend I have to put together my slides, as well as they wanted me to do some updates to the paper, so I got to get that in this weekend. So this is perfect, because this group here really hasn't been, obviously, some of the members of your company, of course, are members of the PERM, but you guys are fresh, so it gives me an idea of, okay, what should I be thinking about as I put my charts together? So sorry about that, but you guys are kind of guinea pigs, to help me put it. So there's also another presentation that I'll be using. That's the background, to the paper from some previous work that we have done here. But anyway, so a little bit of background. You probably recall that we used to have leaded gas, and of course leaded gas turned out to be not a good gas. Leaded gasoline turned out to be not such a good thing. So the idea was to get the lead out of it, and of course, they talk about getting lead out of paint. And anyway, all this has progressed to the point where, we've had to get the lead out of everything. And so, this computer, my cell phone, everything that's manufactured now, is all lead-free. All the solders, joints, and so on are all lead-free. Well, anyway, the question then became, the question then became, okay, if we're going to do this everywhere, what does this do for the reliability of missiles? And what does it do for reliability of aircraft? You start flying these new alloys, how reliable are they? Also, a lot of concern in the medical field, because, how about implantables? You can't have some defibrillator just going off and killing you, So there was a...
I'm sorry.
No problem.
I didn't know if you guys were warm or not. There should be a little thermostat here that you just hit it.
Cool us off.
Okay. Thank you.
Yeah, we'll just keep the door open, I guess. So anyway, so the idea was that, well, okay, the PERM was the risk management. So the PERM was put together really to try to deal with these high rel aspects of design, and in particular, the impact that all this lead-free movement is going to have on, again, obviously we all fly, and so of course that's a big concern, but obviously medical and so on and so forth. Automobile, they've gone pretty much lead-free, except of course the lead, those batteries, they're still lead. So anyway, so Europe's made a big deal about this. Of course, in the United States, the thing that we've initiated is a whole other thing called conflict minerals. I don't know if you guys have heard about that, but basically what that's all about is, we got to be socially conscious that the gold that we use, certain alloys, tin, and so on and so forth, are not being mined in places where people are being oppressed. And so there's all these kind of international initiatives that are going on, but certainly they all impact reliability. Certainly in our case. So anyway, so so what's been going on then is there's been work testing that's gone on to test the reliability of solder joints, especially thermal. Thermal, obviously in aircraft, that's a big impact, because, when you're, especially here in Phoenix, right? It could be, whatever it is on the tarmac, 120 degrees or 50 C, and then plane takes off, you're up at 35,000 feet, it's minus 65, F, and so on, and so you get this thermal cycling, and that's really mostly in circuitry. That's what affects you the most. That's the CT mismatch and thermal exertion. But there's also vibration. You guys, you've flown, go through some turbulence, and so the electronics, see some rough spots, and certainly we want to understand what happens over time, or durability, because like my cell phone, right? It has, it goes through a little bit of vibration, but not much. It just sits in my pocket, and when I fly, I'm buffering the vibration. But again, equipment, obviously, especially when you land, you get those hard landings and boom, they shock the electronics. So the idea is that testing is going on, has been going on. But the thing is that, and we've been working a lot with the University of Maryland, the Kelsey Consortium. And the issue, of course, is that we're trying to, their job is to try to develop models, right? Math models and computer models to simulate the durability and so on. But really, where we're at right now is combined thermal vibration, where the vibration is harmonic vibration. Obviously, in all of the standards that are used for designing aircraft, I mean, we use like, RTCA DO-160, and of course that's random vibration. So the aircraft is subjected to random vibration. And so one of the things that's happened as part of the PERM Research Gaps Committee is we've been studying, and Ron, of course, I did my PhD. He was on one of my committee members, and so he remembers the Manhattan Project that that was kicked off in 2009. To really address this. But I mean, the idea there is that there are a whole series of projects leading to qualification by simulation. But the way we're progressing now, I mean, these models are like a long way off. And so the idea, we got this idea as part of the PERM. Well, how can we leapfrog some of this? I mean, what can we do to leapfrog the development of qual by sim? And one of them was, well, why don't we resurrect an old Honeywell project, which I'll show you the presentation that we did about 20 years ago, where we put electronic monitors, and actually I'll move on to get me to the let me see. I need to get to the the ASME file. Can I hit escape here? Let me see. Where's the escape button on this thing? Oh, there it is. Let's escape and let's go to this. So let me so Dan Robbins, who was my former boss, you remember Dan? Yeah, he's still there. Yeah, the mechanical engineer, and we had a
It's called Haas.
yeah, that's right.
Dan Blocker.
Dan, yeah. So anyway, we have what's called an environmental monitor, and what we did was we actually monitored thermal cycling, humidity, and actually here's a picture of it. So here's a picture of our little black box, literally a black box. What's that?
Data acquisition box.
Yeah, it was a little data acquisition. That's right. Kevin did, and I was his. And then when Kevin left, I took over all his stuff. But we had 9/11 hit, and so we weren't able to develop this to the next level, which was to take into account vibration. And here's a little bit about its functional diagram. But what I want to point out is we placed these in the cockpit of the aircraft, so you see them here. And the idea was to try to monitor and develop PSDs for the aircraft. We have here we have another one here. So these are actually on the cockpit.
Yeah, there's the MCDUs.
Yeah, you see the MCDUs here, our display units, and then we also put them in the eBay. So we put these monitors, you see it over here in the eBay.
That's below the floor where the passengers
Right, exactly. This is like right underneath first class.
Normally you gotta crawl it there.
Yeah. Yeah, and these were, that's a good point. This is for these were on 737 and 777, and so yeah, the hatch actually is right. Well, so anyway, so you have the pilot, right, and you have the door, and then there's a hatch that's like right behind the door. I thought it was curious. I know I'm digressing. That this flight over the French Alps, which of course I also flew when I went to Genoa. I flew into Paris, and then it flew into Genoa, right, and over the Alps. I remember my wife coaching me how to say in French, that hey, do you guys have a policy of two, people in the cockpit, and of course they were like, I didn't know if they were going to throw me out here. Like, wait a minute, what are you doing, haranguing us, Yeah, right. And yeah, but anyway, of course they told me this is Delta. We of course have that. Blah blah blah. So I said, okay, I don't care. Okay, as long as you make me feel good that there's policy of two people talking. But what I thought was amazing is that that pilot. I mean, once he realized after a few seconds he should have pulled that hatch and gotten down into eBay and taken over. You often wonder what's up with that. I mean, anyway. Yeah, so
the maintainers know that, but maybe not.
I don't know. Yeah, I know. I don't know.
Their CAT certification. radiation though?
Yeah, I don't know. Yeah, I was wondering about that. I wondered about that anyway, stuff we wonder about. But if you're in the industry, you wonder about these things. I'll tell you one thing, if I ever suspect anything going on in aircraft, I mean, yeah, I'm going to do everything I can. There's no way I'm going to die in an aircraft, especially since I fly so much, there's just no way. But anyway, so this is the eBay, and you're right, it's just right underneath first class typically. And it's funny because, I mean, first class, you think, first class is what a great place to be. But, sometimes this equipment, might hum. I mean, there are issues that occur, and you're in first class, and you're like, what is that noise? And so anyway, I think it's kind of funny. Okay, anyway, so we developed these back there to try to characterize, try to develop models, especially for thermal models, because the thing that really stresses circuitry the most in flight is really the thermal excursions. I mean, vibration, to a lesser degree, we just throw money at it, and we stiffen up the box, we stiffen up the circuit cards, and and everything's great. But thermal, you're stuck, right? I mean, you get those thermal excursions, there's nothing you can do. You have to, you kind of have to live it out. You got to do things, but pretty much, you have to live with thermal excursions. So that was a very important priority. Yeah, go ahead.
Prior to this effort, what was the level of
The analysis or so on?
thoroughness of environmental requirements for vibe shock?
Well, they've existed. I mean, they've existed for a long time. It just, their specs. Okay, the work here was to develop, to help develop predictive models. And then that was, physics of failure. So that was really the whole goal here. And now the next thing was, okay, now let's do a number of things. Let's look at power quality. Let's look at vibration. And so that was the next step. But again, when 9/11 hit, let me tell you, there was no way they were going to let us get into eBay, put these, monitor these and so on. I mean, the whole program with Kevlar, went down, crashing down. Well, anyway, so fast forward to just a few years ago, when we had this lead-free thing, and that whole thing about 9/11's kind of died out. At least a lot of the issues. So we said, you know what? Why don't we re-resurrect this project? And what we'll do is we'll build a new monitor, and we'll monitor vibration, and of course look at both combined vibe and thermal in terms of data that we can collect, and take this to the next level. Because what we really want to know is how well does lead-free perform? And even though there's an exemption, I mean DoD and airlines and so on have an exemption from using lead-free. The issue is that since like 99.9% of the whole market is lead-free. I mean, they make millions of those and millions of cell phones. I mean, so on and so forth. And our market is so small that the market forces are going to force us to go that way. Management's going to say, wait a minute, it's costing me 100 times the amount to make, a leaded board than it is a lead-free board. We just can't afford it. I mean, that we're going to be forced to go in this direction. So the PERM, our goal is to say, let's make lead-free work. Let's figure out how to make it work. Now, there are aspects of lead-free that are a problem. I mean, there's something called tin whiskers because, there's pure tin. These whiskers grow, and then they short the circuits out. As a matter of fact, there's a woman, I can't remember her name, but she's a congresswoman, and she's been trying to raise awareness because if you probably remember the Toyota accelerator problem, tin whiskers, short it out. Yeah, absolutely, man. Short it out, and boom. So so you can imagine if you have a defibrillator, right, and a tin whisker grows, and of course these things are very small circuits. That thing goes off and you're dead. So the thing is, so there's a real concern. Under pressure, that's exactly what happens. That's right. That's a thinking. That's exactly right. Yeah. So, and they're very small. I mean, they're like the 10th, diameter of a hair, and they're very almost microscopic. But I mean, they do. What's that? And zinc. Yep. Yeah. So you have these issues.
I saw a really interesting article where how in all the I make pacemakers.
Okay, great. Are you with Medtronics?
I was
okay.
until I at retirement age.
Oh, that's,
They laid me off to kill my pension. That, so much for those big
Yeah.
companies, that now I received you, but the
Oh, you're in
floors in
situ.
all our microelectronics factories have zinc in the flooring material in some small amount, and from walking on it, you get zinc dust in the air, and it'll grow dendrites.
wow. Yeah, so I know Medtronic is a real concern. As a matter of fact, they hosted our perm here in Phoenix, I guess about a year and a half ago, during the winter, of course, during the winter months. And got to hear about their concerns. I'm sure St. Jude has the same concerns. But so as part of this, lead-free, I mean, the major issues, around tin whiskers, the area I work in mostly, I mean, I do some tin whisker stuff, can't get away from that stuff. But most of the work I'm doing, of course, is developing predictive models, for soldered joints. So anyway, so we're trying to do a similar thing. One of the things we did find is in these benign areas like cockpits and e-bays, we think that we're going to have good success with our current designs, but the real question comes in: what happens when it's in an engine controller? What happens when the electronics is in a harsh environment, harsh aircraft environment, helicopters, especially these helicopters that travel to oil derricks, and high humidity and so on. So our real concern in this is one, looking at harsh environment, looking at obviously the lead-free under thermal and vibration environment. So the idea is let's develop this to characterize. So there's a little bit of background here.
So you're developing a physics of figure model?
Well, what we're doing is we're developing a monitor, and I'll pass that around in a moment. Yeah. So let me go through. This is the stuff now I'm not going to present just. The only thing I want to point out about AVSI is that this project's under the auspices of AVSI, as it was before. So the previous was under the AVSI is it's the Aerospace Vehicle Systems Institute, and it's out of Texas A&M. So Texas A&M University.
You have to pay to play.
You have to pay to play, right? And now of course Honeywell is and Honeywell Honeywell is like a corporate sponsor. Yeah, exactly. So that's right. So we're and I go around pitching this thing. So I don't know how many times I've given this, different versions of this pitch, because obviously we're trying to get companies like Raytheon companies.
Raytheon used to be a member, and then they found out, and I think they're back in.
Yeah, I don't know. I'll have to check with Dave, but you may be right. And so there's a number of companies. Yeah, Boeing, Rolls-Royce. I mean, there's a number of international companies that are part of the AVSI consortium, and really the main reason for it, one of the things they exist is, of course, to collusion, because they work through that whole issue. I mean, you can't have, they help work through that, because I mean you can't have all these companies. Exactly. I mean you gotta be careful about this, and that's why this presentation. I mean, I give it all around the world. I mean, and we, like I said, the idea is that right now we're trying to kick off a requirements gathering phase. So we're just at the beginning of this project to figure out what requirements do we need, because this thing is we're looking to put these on aircraft and actually have them live in aircraft to get the real environment, as opposed to accelerated testing. We want to, now there will be some accelerated testing, because we're also looking for aircraft that do quick hops, these quick hops, so we get a lot of thermal cycles in. Regional jets, but that's about as accelerated as our thermal is going to get. But we feel that we should be able to take that information and extrapolate acceleration factors from there. So anyway, so we're under the AVSI, and like I said, we're focused on the harsh environment. We have a tin lead monitoring board, and we're looking obviously to figure this out. Statistically significant sample sizes. I mean, how many of these do we need? Oh yeah, we have, here's our latest box. Looks like this. As a matter of fact, I told them our designers, and it's probably not going to look like this, because we're working, it's not the monitor that's the focus, it's the lead-free one. So I said, hey, why don't you take my dimensions of this cell phone and use that. And there's a two-board, the idea right now is get a two-board configuration. The monitor board is the one that has the event detector on a chip, and then this board here is the one that will have, you know, all the lead-free devices like leadless devices and so on and so forth.
It's a test board.
Yeah, it's a test board.
Doing this on a actual LRU on the plane.
No. Yeah, this thing is just like that other one. It's just, yeah, all those are, there's a battery, right? There's a battery in that little black box that you saw. It's about this big, right?
And just collecting temperature.
Right, and those were just collecting temperature, humidity, environmental data. That's what those did. Okay. Now what we're doing something else. We're also, and as a matter of fact, let me jump to the architecture here. Let's see if this thing should. Yeah, here we go. Okay. So what we have is we have a monitor board, right? So here it is, right? And then we have the little piggyback board, which is this guy. And there's also power module, and the reason for that is because we're either going to power it with battery, or we're getting actual battery. We're actually getting aircraft battery, and part of that is because GE Aviation is really interested in FPGAs, and I need 5 watts of continuous power. So anyway, so we're right now.
So when it says pressure there, is that
okay? So now these
like,
okay.
Stress strain.
Well, no. This is to get to figure out our atmosphere. It's atmospheric pressure. Yeah, and these are actually this is kind of interesting because what happens is that this board, right, will be this board is like our DOE board, if you will, because we'll have factors that we'll be looking at, like as a function of various components. We'll be looking for different levels or categories of, for instance, alloy, right? So we use SAC 305 as a typical baseline alloy. SAC 305 is tin, 3%. So it's mostly tin, and then it's 3% silver, and then 0.5% copper, right? We're also looking at, we've been doing research on bismuth-containing alloys, and so especially one that was invented at Los Alamos. So there's a number of different factors that we're looking there. We're looking at different finishes, different alloys, the different solder alloys, and so on. And then, of course, the responses that come out of that are, the resistance, because it's a event detector on a chip. We're measuring time, and we're measuring voltage. And then the covariates are all these guys: temperature, humidity, vibration, and so on. And we've been actually, Doug Montgomery and Connie Bohr have been working with us and came up with this scheme of, well, why don't we look at all these as, as covariates, and then we'll do the design of experiment here and set the different levels. And this monitor will be collecting both sets, and then there'll be some post-processing that's done. But if we have actually have aircraft battery power, we could actually do some analysis on the chip. But the idea is that if we just have a battery, we'll do some post-processing to assess failure and characterization of covariates.
An accelerated life test experiment?
No, it's on an aircraft.
Oh, so this isn't.
Yeah, it's on an aircraft. These little black boxes are going to strap, just like you saw the pictures before.
Okay, so
same thing. They'll be on an aircraft.
Exactly.
That's right. This is self-contained, and there'll be like a battery module. I'm not saying it's going to be this big, but there'll be a battery module, and then that's it. It's self-contained. Right. Exactly. Yeah. There'll be on the board. Okay, that's a good question. Yeah. Like for instance, this one will be, let's say, SAC 305. Okay, and then there'll be another guy right next to it, and it'll be our baseline. Let's say tin lead. What's that?
You're using different package types?
Yes, yeah, different.
That attachment, then
Yeah, right. We have.
they're all going to be identical, and they're all going to be biased the same way?
Oh well, no, they're. Oh yeah, that's a good question. They're dummy components. They're those daisy chain. Yeah, daisy chain. Yeah, they're daisy chain components. But that's the lead-free experiment, and then. And then GE Aviation is interested in a special test board where they'll be looking at an FPGA, an active processor.
So you're looking totally for mechanical failure?
Yes. Yeah, we're looking at thermal, mechanical, but the now the GE folks, because they've just come on, so this is all new stuff, right? I mean, we haven't even kicked off the contract requirements phase, yeah, they're looking at single event upsets. You know, they're looking at wear out. Yep. So that's their interest, and so that's why one of my big sell jobs to the aircraft folks that are, you know, that are signing, or hopefully they'll sign a contract next month, is, hey, you know what? We need battery, we need power, because these FPGAs that they're looking to use are like 5 watts. I mean, they're consuming power, and so.
So you're saying you're worried about single event upset?
Yeah.
It only happens at like 30,000 feet.
Right. Exactly. Yeah. So there's different experiments that we're doing. It's one monitor. So we got this one monitor with all the processing, and this, of course, is tin lead, because, you know, that's the stuff we trust, right? But this little piggyback board will have various types of experiments writing on it, and so that's the current idea. I'm sorry?
So there will be power.
Well, one version of it will be. Yeah, right. That's right. There's two. Yeah, because there's one. Well, the way it all started, you know, you have to work to try to get people on your team, right? So the way it all started was all we were ever going to do was run these dummy, you know, daisy chained dummy components, you know, resistors, caps, you know, BGAs, but again, daisy chain parts from Practical. And that's all this was going to be. But then GE, who's a big player, said, well, wait a minute, guys, you know, if you can get me battery power. And what excited me about that was because Boeing military, right, I mean, they're willing to give me aircraft power. So I thought, this is great, because, I mean, I'm really trying to get this technology tested in harsh environments. And so if I can get this on military aircraft in, you know, where there's gunfire, then I can really shake and bake these babies. Oh, yeah. Well, like I said, on the monitor board, it's an event detector on a chip. So we're measuring resistance. You know, resistance of the dummy components, like the BGAs. You know, they make those daisy chain parts, and yeah. Well, there's for vibration. You know, we do vibration testing.
But fit in there with a bias on it, right? Because otherwise you can't measure resistance.
But he's measuring resistance, so there's got to be some voltage.
Yeah, because it's a solder joint resistance.
It's not
No, they don't need it, right? It's not functional. No. Yeah, no. They're just, yeah. Exactly. I mean, that's all we're doing. Yeah. Yeah, and we use, well, I mean, yeah, like the solder joint resistance, right? That's typically, yeah. And we've been doing this kind of stuff for, I don't know, you know, decades, using either an Anatech, you know, that has a 20, you know, it's under, what is it, IPC 785 per IPC 785, IPC 9701. And so we use, you know, to either Anatech or an Agilent, but we use the Anatechs because they have a 200, you know, they're continuously monitoring and will, you know, will monitor, you know, an intermittent at 200 nanoseconds, and so that's, but all of that, like, you will, you know, event detector on a chip, monitoring, you know, continuously monitoring, obviously it's polling, monitoring the, you know, the resistance. Oh yeah, right. So, well, okay. So this is the requirements. This is the requirements phase we're getting ourselves into. You know, this is really the reason for having that phase, because that's where because we have to design that event detector on a chip, and we have to look at, okay, you know, how are we going to do that? So we're not there yet, but we want to at least establish the requirements for doing that. So
it's admirable that you're doing this, and, you know, Kelsey's been spending tons of money for all these sponsors trying to come up with a model. Right? What's the model that if you put it into these covariants, this is going to form the tin whiskers?
Yeah, it's in.
They don't know.
They don't know. What's interesting though is you mentioned, you know, Kevin Clough, right, who did the thermal piece. I mean, that was his PhD, because he did his PhD at Kelsey, and they took all of his stuff, right, and incorporated in their, you know, in their code. And so they're still, you know, selling Kevin's stuff from, you know, 20 years ago. And so we know this is valuable because, you know, I mean, these guys are selling the results of this work because, you know, it really related to to real service, in an aircraft. And that's what we're trying to do here. What's that?
I was just saying, so it really works. What changes to the aircraft or things have been the result of this type of thing?
Let me phrase that question as, has the FAA said, hey, let's change some of your aircraft requirements or something, or no, it hasn't. I mean, what it's done is it's allowed qual by sim. It's allowed the fact that you could actually estimate failures in your design, and that's really what it's done.
Accommodate differences in, I assume you're on some kind of PC board,
Mm-hmm.
and so you must have a wide variety of materials for your PC board.
For the lead-free experiment.
You know what I'm saying? Because that's a significant factor in this.
Right. Some of the factors are, and actually I don't have them here. Yeah, we're using SAC 305. Oh, I'm sorry. Right. They're different finishes. You mean the finishes, the board finishes? Yeah, the board finish like Hassel, right? Hassel versus OSP. Oh, yeah. Sure, the laminate. Yeah. Yeah, we'll be looking. Yes, we are. Yeah, the factors are. So that's a good point, right? Yeah, the factors are we're going to be looking at laminates. Like ISOLA 3. What is it? 375 or something. So we're looking at a couple of different laminates. We're looking at Lou's saying, different finishes, and we're looking at anyway. And so those are the different factors. And again, during this requirements phase, one of the things that again, the PERM members who are signing up for this, we will be making those decisions. Now, what's been going on? I've been working. Yeah. No, sure.
Is your boards going to be hermetic then?
Hermetically sealed. Well, this is a good.
That's it right there.
Well, this is no these. Well, yeah, these are all 3D printed, so these are we're not using this stuff. It's just to give you an idea. No, but no, that's right. No, that's great. Go ahead. Yeah.
And
Okay.
then you get leakage paths. Then you get.
No, right. So this requirements phase. Hi.
Can you do anything about it?
Yeah. During this requirements phase, we're gonna identify all the factors, and we're gonna have.
What do you guys use for PC boards? What materials do you use?
Well, you mean the laminates?
Do you use? Yeah.
Oh yeah, we use high T sub G boards.
Huge difference.
Yeah. Well, that's one of the things we're looking at because we've been doing studies looking at two different the latest set of papers that we published. We're looking at two different T sub Gs, so that's one of the things we've been looking at. Bismuth containing alloys. We're here when I talk about bismuth containing alloys. Anyway, but the idea behind this requirements phase is to actually select the factors, and select, how many levels of those factors, we'll be using. And so we've got like the, material science. Actually, there's a lot of material science folks that are part of the team. There's probably, there's me as a mechanical engineering guy, and we have electrical engineers. So we have a group of folks, especially a lot of the electrical guys are in GE Aviation. But the idea is that during this requirement phase is to spell out, what are the covariates we're going to be measuring, what are the different levels, that we'll be examining for the lead-free board as well as the active boards. So, and so anyway, yeah. And we have, I'm trying to remember the guy who's on the perm from Medtronics. His name will come to me, Peter. I can't remember his name. Anyway, so we get inputs from all our perm members, but obviously when we go into this phase, it's only AVSI, only whoever pays up, will probably get to drive the design a little bit more. So let's see what other things that I want to tell you about this. But good questions. Actually, where's that arrow? Oh, yeah. Oops. What did I do? Oh, yeah. So let's see, get the AVSI thing. Here's just a little bit. I have to give the group we actually voted for it to go on. We the Army actually suggested something that they use, they call it the Firefly, and they have, and I think one of the ideas we'll use is certainly use a device that we can plug into and pull all the data off the memory, and then these little pods get placed in various places on the aircraft, and this is actually also a power module. So we haven't really settled on an architecture, but the Army certainly is really excited about this. So is the FAA. Actually, they're the most excited, especially the FAA, because FAA, and I know, I mean, they know that this stuff's already in the product stream. Certainly it is, in terms of displays. So I mean, their big concern is, obviously, I mean, safety of flight, knowing that. What's that?
Who is your Army customer?
They're the guys at the Redstone Arsenal. Yeah, in Huntsville. Yeah, that's where they are. Yeah, Dave Locker is the guy, and he's a great guy. So anyway, so this is what he's offering some of the work that they've been doing. So it's kind of a small little processor here. And let's see, we've got some interesting trade studies going on in terms of batteries, and one of them is that we still have our batteries from 20 years ago, our lithium, our lithium-ion batteries. We have some that what are called old new batteries. I mean, they're brand new, never been used, that we bought as backup for the experiment. And then we have some that we actually, put on the aircraft, used up. So we've got this study going on to really understand the, long-term life of batteries, both batteries that have never been used and batteries that, have had a lot of charge-recharge cycles. So that's kind of a cool trade-off there. We want to really, have an opportunity to study that, because again, we may have to have a configuration where we're not going to have aircraft power, even though I'm begging to have aircraft power, but we need to do these studies. And of course, these studies are important because you've probably heard about, the Boeing, in Boston, the batteries that blew up on the 787. When was that? Like a couple of years ago now? Yeah, a couple of them were grounded. One in Japan, one in Boston. Yeah, it's 2 years ago. Yeah, that they had bad news with. Let me tell you, that threw a tailspin into this project. Because the reason why this thing is so big, you're wondering, why is it so big? I mean, not only do I have to explosion-proof this thing because of where it's going to be, like in the tail where you have fumes and so on, I had to put flame arrestors, but it also has to be fireproofed because, those lithium-ion batteries, they cannot catch fire, and they cannot. Anyway, I got a lot of work. Fortunately, I mean, I've got a lot of experience in making stuff explosion-proof and fireproof, but still, I mean, it makes the thing bigger, bulkier, but it's a big consideration. I mean, none of us want to have some problem, some aircraft crash just because some dumb experiment, that blows up.
The reason they're so small is so you can stick them in all different places, all right? I mean, there's no...
The boxes, you mean?
Yeah.
Yeah.
The test box,
yeah. Yeah, and so we put them, but really what I want to do is, of course, get them in these, well, like for instance, I'd love to get them up, up at the tail, because, you're going to get a lot of vibration there, and of course, it's in an environment that, in an explosive environment, yeah, and there's in different places, and get them up. So there's certain pet places that I have that I want to put these in to see if we can't fail them, because obviously they're going to be, when we do qualification testing, I mean, it's accelerated testing, and within a few hours, I mean, we break the stuff, right? But obviously when you're in an aircraft, I mean, they're going to last longer, right? They're supposed to last longer, but the question is, how much longer will they last in comparison to our standard tin lead? And the other things that we don't know is that, certain alloys, right, with certain finishes on the boards and certain laminates, will probably fail earlier than others. We see this in studies like pad cratering, for instance, on the laminate. So there's, we want to really understand these various modes of failure and what combinations of alloys, because, maybe, not one size fits all. You might realize,
What is that second bullet?
This one here?
Comparing lithium-ion
Oh, yeah.
capacity or number of charges.
Okay, well, what happens is that, right, your battery, you can charge it and then discharge, charge and discharge, right? And so this,
Comparing what?
oh,
Comparing lithium battery capacity versus current discharge? It
uh,
says or, I'm just being thrown by the word or there.
what, okay,
What do you compare?
oh yeah, well, this charge discharge, I mean, it's the same thing. I mean, I'm just calling it that. Battery, some people call it battery capacity, but it's just charge discharge cycles. Remaining between the batteries, right? Stored. Yeah, see, I'm comparing between the brand new batteries that have never been used before, charging and discharging those, right? Versus,
It's a different term. Right? Capacity is
well,
the ability to hold the charge. Where you're saying here, the number of discharge charge cycles, that can affect the battery life as well. But I think you're
yeah, here,
Except you
yeah,
think about with time, the
right.
chemical reaction takes
Right.
place.
your
you lose
capacity goes down.
The capacity goes down with time. But
And then I assume, I don't know how your batteries work, but there's a difference between whether you cycle them totally up and down or whether you top them off.
exactly.
For lifetime.
For these, yeah, then, yeah, for these, yeah. So, the idea here is that we're going to run for 3, this is the other reason for doing this, because we will run them to total discharge because, I mean, that's what we're doing. They're going to be on an aircraft and they're going to discharge. We want to get them to full discharge before we charge them up again. And then replace the modules, the battery
Just a
modules.
little food for thought.
Yeah, sure.
That whole comparison.
Yeah, because we're comparing,
So long of a
right.
sentence, I'm getting lost on what you're
Okay.
actually comparing.
yeah, because we're comparing, right? We have batteries that are 20 years old, right? Some that have never been used and some that have. And the question is, if you get a brand new battery, right, does it charge and discharge? How different is it from a battery that's been charged and discharged in a real environment back 15 years ago?
Versus in-service life.
Right.
So you want to know a 15-year-old battery compared to a new battery, how long does that battery last?
Yeah, the comparison between an old, well, these are all old, right? But some have been
Batteries
used
they're 50 years.
20 years. Yeah. Yeah, and they've been sitting there.
And how did you isolate the non-equivalent that you're calling it? I mean, is it really the equivalent of a new battery?
Oh, well, we don't know that.
It was charged originally, right?
Yeah, right. That's
But
right.
it's probably discharged.
Probably discharged. Yeah. Yeah. By now, you would think by now, but yeah, we bought a whole. It'd be curious. I don't know. I mean, we have. Yeah, go ahead.
Well, the discharge rate's about 50% per year.
Yeah. So I mean,
We have not an unreasonable temperature.
yeah.
You shouldn't have lost more than 10%.
Yeah, it'd be curious to see.
We literally measures the version of the batteries.
Yeah.
10 years old.
Yeah, I'd be curious to see what they're actually at. It's just that this came up and I said, you know what, we have an opportunity here because I asked our tech. I said, hey, whatever happened to all those batteries? Just, oh yeah, we've had them. After these had to get after 9/11, they got pulled off the aircraft. This is Roger Bidness. I don't know if you remember Roger. Anyway, he's been there forever. And I said, Roger, and I got him on the team. I said, Roger, whatever happened to all our old lithium-ion batteries? And he says, oh, we've been storing them, at room temperature for like, well, now, but since 2000, yeah. Yeah, it's been. Well, not that I know of, but I'll tell you one thing. We've, like I said, I've got all this data, quote unquote data. Batteries have been sitting in storage because what they did was they bought a whole bunch of batteries 20 years ago for the study, right? And they never used all, they were all charged up initially, right? And a whole bunch of them they've just been sitting there, right? And then there were the ones that you saw in those pictures that got into aircraft on and off. And those were, of course, those were charged and discharged and so on in these little monitors. And of course, they took those off the aircraft and again, stored them. And fortunately, they were stored separately. Yeah, exactly. That's basically it. Yeah, because we figured, you know what, we really need to understand this lithium-ion stuff probably a little bit more, and we have an opportunity. Let's take it. And this was precipitated mainly because of that whole, explosion thing that occurred on the 787, which I have to admit that was all, obviously Honeywell's, one of our subcontractors, batteries. Anyway, it's a story in itself, right? Oh, they're I had a picture. I guess I didn't. I guess I don't have. They're like this big. They're what is it? D size? They're D size batteries. Yeah, they're D size. Let me see if I get more. Design of experiment. Okay, so of course. Yeah, he is. It's funny. I was out. Where were we at? Anyway, we're somewhere, and I think we were in England, and last year. And I said, so Lloyd, I mean, what's up? He says, oh man, I'm ROJ. I said, I can't believe, I have never heard anyone say that about themselves, No, retired on the job. and because, I mean, Boeing flies him like all over the place. I can't believe he said that, but I mean, he says, hey, you know what? They don't stop him. He flies wherever he wants to do, whatever he wants to do. Hey, I mean, geez. And he goes to conferences now. He just pontificates. I mean, he doesn't have to prepare or anything. Just, oh, Lloyd's here. Okay, Lloyd. Goes off and says whatever he wants.
John Fick, is he still around?
I don't know John.
I remember when he retired.
But anyway, yeah, Lloyd's still around. He'll always be around. He wrote a book on reliability, as you know. Yeah, well, I'm just familiar with the one. What's that? Yeah, Design for Right. Yeah, so.
No, he didn't do Design for
Yeah, he did. Yeah, he wrote that book. Yeah, I'll bring him in a copy next time. I can show you his book.
He's only three that I know of. So I have one. Alec Feinberg has one. Some guy named Eric, whatever.
Yeah. So the good news is here, as you can see, I mean, Lloyd, when we kicked off this, Lloyd said, you guys have to really do a good design experiment so that, we address questions like yours, make sure you get the right laminates, blah, blah, blah. Lloyd went on and on and on, and he said, and you know what? Doug Montgomery, if you can get Doug Montgomery to work with you guys, and of course, Doug was my PhD advisor, so of course that was a pretty easy thing to do. So I said, oh, perfect, Lloyd. Yeah, of course, we'll work that. And it wasn't much of an effort, but anyway, the idea was that, he really made sure that, he wanted to make sure we were doing the right thing. And so, of course, that was, we're in luck for this project. And obviously, I mean, these, we want to make sure we design the experiment correctly. And of course, the various factors of interest. Here's a model. Obviously, there's main effect models, but models with two-factor interactions gets a little more complicated. Obviously, we're looking at a lot of categorical factors, right? Types of solder, type of board finishes, components, et cetera, et cetera. So we got to get smart about what we're doing here. But these experiments can grow quite a bit. And of course, the covariates. So all this data that we're collecting. Obviously, the daisy chain resistance. And here, this is from a paper we just actually was just published in IMAPS, where we actually, I guess it's kind of hard to see, but we've been doing studies. So here we have 1, 2, 3. There's SAC 305, 5 different alloys that we studied, different T sub Gs, and finishes, and we used the Latin square. And here are some of the failure times doing a screening experiment, because obviously we can't put everything on the aircraft. So we've been working with NASA DoD is one project. This project we got funding from the Canadian government to look at these different alloys. Part of why the Canadian government gave us money was not only for aircraft, but also they're really interested in being like a world fabricator of solar cells and so on. So I mean, so we're looking at a bunch of different lead-free, and obviously they're subject to all the lead-free production of electronics. So anyway, but we've been looking at alternate alloys because of the problems with pad cratering. Obviously, the low melt alloys have a lower melt temperature, and so of course that saves energy. So there's a whole green thing, sustainability thing going on there with the Canadians. Anyway, but my goal in this project was, and in other projects that I'm involved with, is how are we going to do this? Let's get data to get a down select, because we're going to put this stuff on an airplane. We need to be down selected to the smartest alloys available. So that's the so anyway. So it just gives you an example of what a design array looks like, and obviously these are some of the next steps that we got going. So anyway, that's the end of that one. So anyway, I don't know. So anyway, so these two, like I said, I'm working on my charts, but at least on this trade study one, I'll fix that one, because I think people need to know we're doing this trade study, and so I'll fix that chart up. Yeah, the battery chart. Yeah, I got to fix that. So I'm glad you brought it up. Yeah, okay, that's good. That's good. I'll fix that. So yeah, because I get. So anyways, that's some of the stuff that's going on. We have other work going on. You know, test vehicle testing. Yeah, go ahead.
Test units under test there, will they be conformal coding, or is any coding part of the permutations being evaluated?
Well, the team. That's what I said. I mean, I got this team. You know, I'm leading the team, but I'm letting our material science folks. You know, I want them to decide. You know, I mean, I don't want to decide. You know, I mean, usually, and for the students, obviously, you know, when you're in a company, I mean, you always work. You know, you always work in a team, and you get the reliability department. There's all these different departments that you work in, and certainly my expertise is not, you know, in material science. Even though I did a minor in material science in graduate school, I mean, you know, it's like when I think of a material scientist, it's someone who has a degree and has 30 years of, you know, working that. You know, so there's a lot of things that you know. I mean, in some things I feel like I'm a dilettante. I mean, even though I might have taken a bunch of courses in something, I feel like if I haven't been working on it with, you know, 30 years of working in some specific area, I feel like, hey, wait a minute, you know, there's somebody else who's got that degree and's been working 30 years, you know. And so, but I think part of the reason why we take on projects like this, and again, this is more for the benefit of the students, right, is, you know, when you're in a large corporation, I mean, you know, what gives you confidence in taking on projects is knowing that you have the experts and within the company that you can bring to bear. And not only that, as you get involved in different consortiums and groups like this, I mean, you know, you have people that you can draw from. And so it's not only within your corporation, but a consortium. So the PERM consortium, I mean, we've got all these experts from around the world, you know, in lead-free that, you know, that are available. And you know, we're developing different standards, lead-free handbook that we've got going that we're trying to get, you know, the medical industry to help us out. Philips is our, you know, the European group, but here it's Medtronic, and I haven't seen anybody from St. Jude, but I know certainly Medtronic is, you know, as part of the PERM. So that's the other thing. So there are these different consortiums, and of course, you know, like I said, you know, IEEE, SME, and so on. You know, you get involved in those committees, and again, you know, you network with those folks to figure, hey, you know, who are we going to get to work through the expertise? Obviously, there's the various conferences. So again, you know, you keep the whole network going to bear on problems that you have, and so that's why it's important to go to these conferences. And sometimes conferences, of course, nowadays I only go to conferences that I want to go to and are fun. That's why I can't wait to get to Boston. Yeah. Anyway, I'm done. Yeah.
When you get something done, you're going to build thousands of these.
Yeah, we are.
Devices to put them on enough planes.
Right.
You're going to build an extra 50 or 100 to put in accelerated testing.
We are. Well, let me put it this way, because the FAA is part of our team. So the FAA, we've got a test plan. The first thing we're doing, okay, this is a good point. Yeah, these are all, we're going to go through qualification testing on the ground first. I mean, I got it, you know, and that way we can rack and stack what combinations are, you know, how they're going to rack and stack, right? I mean, which ones are going to fail first, and so on and so forth, to make some selection as to which ones we're actually going to fly. The other thing is that we also have a UAV, at Texas A&M. They have, the great thing about Texas A&M is that that whole, whatever it is, that university system, they have access to national airspace, and they have a huge, you ever been to Texas A&M? They have a huge avionics lab. I mean, the airstrip, I mean, you can't believe it. And they're always doing these UAV tests. And so we're going to get, so once we do the qualification testing, we're going to put these guys on the UAV, not so much for the thermal, but for the vibration. So I'm working, so they're part of that team, you know. So part of what AVSI is, right, is in Texas A&M, but I mean, obviously, you know, they have a university and they have experts there, and so, you know, we want to bring in that piece of the team. But AVSI is set up not to send, you know, what do you call it, channel work to Texas A&M, because obviously, I mean, you know, we're working with ASU you know, University of Maryland. So I mean, AVSI works with a bunch of different universities, you know, and they're really easy to contract with, let me tell you. And so, anyway, so the next thing we'll do is we'll put it on a UAV. And so before we really get an aircraft, and not only that, but the aircraft we're planning to get on are also owned by the company. So they're the experimental aircraft. before we then, get onto, let's say, revenue aircraft like like an Embraer or a Bombardier aircraft. So there's these steps that we have planned to take so that we kind of manage the risk. Because again, I mean, there will be no question about it that you'll be flying on some Embraer aircraft on a quick hop, and guess what? We got one of these AEMs on the tail or something, or by the engine. Hmm? No, well, they'll be in these little metal boxes. Oh, I'm sorry.
Your real intent was to use this as a way of taking a read if you change your other boards.
Oh yeah, for regular, yeah, avionics, sure.
Does the plane have all
Not.
boards all over the place, or are they just sort of concentrated?
Oh, okay, no, yeah, that's a good question. They're in different places. Like, for instance, I'll give you an example. On a Boeing 787, they have something called a gust suppression. And so that's up in the rear tail, and oh yeah, they're in all orientation. Yeah.
Sometimes you've got gravitational force.
Yes, they are. Yeah, they're different orientations. The majority of the black boxes are in the eBay. Yeah, there's a door. Yeah. Well, I don't know. I mean, I guess this is public knowledge, right? It should be anyway. Whatever. Yeah, they're probably lashed or something, because I know.
Also get through it through storage, right? So where all the bags go, luggage, you can get it through the.
That's right. But.
Not sure representing real life.
It just seems like this is a very complicated.
It is.
A human body is a little more benign. It has a different set of problems. So you've got a beating heart that holds on the leads type thing.
Oh yeah.
But it just seems like you'd also have to worry about your orientation.
Oh yeah.
Or vertical versus horizontal or whatever.
Yeah, we're not too. I mean, I don't think that's as big of a deal, but yeah, but you're right. I mean, and so our board laminate. I mean, we have, like I don't know if you know Vic White, but I mean, like Vic is our board. Guru, and we have all the different gurus of, that go into making this thing up. That the different IPC committee folks.
I'm sorry to interrupt you.
That's right. I'm basically done. I'm in the Q&A section.
St. Jude is doing related to that heart sensing valve. I know the guys at Micron. They showed me that video, the one where you insert it in through an artery, and then it opens up, and it's got a sensing for the heart. How much pressure to the oh really? That's pretty popular. It was St. Jude that was on the marketing
No, I
material.
know, but I think everybody's in that workspace.
Oh yeah.
It's competition.
But it's all going through Micron Instruments, right? For the stress strain
I don't
gauges.
know about that. I'm in a different division.
Well, let me ask you this, because I mean, my understanding, certainly in the implantables, I mean, the concern with lead-free is, of course, the tin whiskers. But is there any other, lead-free type concerns that you guys have?
Because we're just making the switch. That's why I'm very interested
Yeah.
in what you're doing.
Sure.
Because if there's a problem, we're a very small company.
I know. I mean, yeah.
If there's a problem, there's only a couple people who will have to figure it out.
Right.
We don't have armies like you guys.
Well, but again, yeah, that's right, through the network. That's why, yeah, I mean, it's a network of, yeah.
It's a very different ballgame.
Yeah, at St. Jude, yeah. Okay, well.
Excellent.
Guess that's,
Thanks for that.
yeah, you're welcome. Thank you.
Good luck.
Yeah, good luck getting all these companies together.
Sure, Boston won't be later. Give the microphone. I've got a couple now.
Yeah, let me give this back to you, and I'm trying to.
I got some Rams pens. Anybody wants Rams pens? The Rams towers.
That was great.
Only give me 20 minutes. So,
Did you?
you guys indulge too.
Arg.
There you go. Yeah.
Have we dropped?
And Ron, is it possible to make copies?
Mm.
Copies, we copies?
Yeah.
Did everybody sign? Everybody sign? Okay.
Well, I apologize. Looks like we may have lost our connection on this one. But
Say, I don't know, maybe some folks might want 10 copies?
Or you can take pictures if you want.
Oh, yeah, take a picture, that's true.
while we were on the thing, I got a email from Randy. He got an email from ASQ that lists out all the webinar lineup for May. So he said that's probably of value to everyone here. So we'll forward that out to everybody. It shows all the webinars that are upcoming through ASQ for the month of May. So I'll forward those out. Also, I'd like to say thank you to Dr. Pond, and all of his students for arranging the room for us and the pizza and hosting us. We sure appreciate it. And I think Dr. Pond is going to give us a 10-15 minute overview of the program here. So I will turn the floor over to you at this point. Did you get that?
Well, first of all, I want to thank Joe and have the invitation.
One of my favorite topics.
Hold on. Well, first thing I want to talk about is just, I guess most of you just the first time come to ASU and come to this building. So just a little bit introduction of our school. Ready? Okay. All right. So a little bit introduction of our school, and the building you are in is called Brickyard Building. Actually, it's a little bit outside the main campus. We're really not in ASU campus. It's in the downtown of Tempe. You can see that downstairs there's a lot of restaurant and bar. So especially during the weekend, I mean today, I can hear all the noise from my office. So, so the school is called Computing, Informatics, and Decision System Engineering, and we actually have 3 groups in the school. The biggest one is computer science. Okay, and our group is industrial engineering. Okay, and there's another group, software engineering, is in the Polytech campus, actually in Mesa, not here. So the big school probably have 70 to 80 plus faculty member. So it's really a huge school. In our industrial engineering program, let's see. Oh, just an introduction of ASU in general. Actually, this statistics is a little bit older. It's from 2013, so two years old. So now must be more than 70,000 students in ASU, and they claim to be the biggest university in the United States. Yeah. No, number-wise. The student number-wise, and ASU little commercial. There's they talk about 3 things: assets, excellence, and impacts. Assets means almost everyone can come to ASU, pretty much like that. And excellence, try to stress excellence in teaching and also in research, and more importantly, ASU's emphasize on impacts in the society. So there's a lot of things going on, and make ASU kind of unique and different kind of university. For example, as our faculty, I don't know if you're familiar with academia life. They say publish or perish, right? So you have to publish. Well, that's the typical measure, of your productivity. But ASU also count for example, if you invent something, intellectual property, have the entrepreneurship. Those type of things they also count. So anyway, Student enrollment in our program actually, is up to 2013, but the general trend you can see always growing, getting bigger and bigger. So now IE program, we typically have now roughly about 50 PhD students. And today I have 2 PhD students here, Kang Wang and Dong Jin, and 1 master student, Arun, here. Okay.
From 67 to 45.
Well, yeah, well, it up and down, but roughly 50, I would say, yeah. Well, for one thing, for sure, that the quality of PhD students getting better and better. All right, so our IE program is, well, we have a very good research group in industrial statistics in quality and reliability area, and Joe mentioned Don Montgomery and Connie Bohr. She's also one of our agent faculty, and George Ranger, me also in this group, and Dr. Li Jingli, she's also in this group. So and actually, we attract a lot of master and PhD students because of research in quality and reliability. So and we have another group in manufacturing, logistics, and also in information systems, and some faculty get into healthcare delivery and healthcare system, those kind of thing. All right. That's where our students go. So I will just talk a little bit about my research, and I'm glad that someone mentioned the conference in Boston. Right? Joe, you will go there, right? Okay. And Kang Wang just submitted an abstract to there, and that's pretty much his topic over there. I hope his abstract will be accepted and he can go to Boston. So, well, basically, my research is about part of my research is about accelerated lab testing and how to plan accelerated lab testing. And you all know the challenge of analyzing failure time data, censoring, non-normal distribution, and you have to build this acceleration model, extrapolation, and so on. But what we feel that there's really inefficient use of design experiments in accelerated lab testing, probably for a couple reasons. One I can think about is, most of those tests, at least a couple of years back, you just accelerate one stress, and you bake the parts in the oven, that's accelerating the temperature, and there's no need, pretty much no need for design this experiments, but more sophisticated instrument. Now you can combine different kind of stress together. Okay, and then there's a question is what kind of testing conditions that you will set, and there's so many combinations, and to pick several good combinations can help you more efficiently to carry out the experiments and get maximum information from the experiments. So that comes to play the design of experiments. And my research mostly is on optimal design. Okay, how to design the the experiments such that you can obtain the maximum information from the experiments. And there's a couple optimality criteria, and that's one example. Basically doing the thermocycling test, and even in this test there's a couple factors that you can play around, like the downtime and the temperature, amplitude, and the cycle time. So there's at least 3 factors that you can play around. And also in those tests, there's a lot of constraint, not just from material, from equipment, and from the management requirement, and so on. And also those tests are very expensive, and it's just very few test units. And so all those constraints made this experimental space very irregular. And we did some simulation and get some result from here's a comparison of the optimal design with a standard design. And basically the y-axis is the variability, okay, of your model parameter estimation. So we can see that the standard design could have very high variability, and even when you have very large number of test units, okay. And the worst part is, for example, here you have over 100 test units, but through the test, you still could not tell whether or not a factor is significant or not. So that's why we need the optimal design. All right. So more recently, we developed an R package, and can help user that to choose the optimal design. And so it's mostly Kanwan's work. So with this R package, well, basically here's the design region, and based on model that it can calculate, where to put your test condition. In this example, 4 testing condition, and those circles represent how many test units to be located there. Okay, so here's the use condition. So obviously, that's reasonable. You put most units close to the use condition. Okay, but also try to have your test condition, spread out as much as possible in your design space.
What are the axes?
Oh, those are 2 stress factor. Okay, those. Yeah, one like maybe temperature, one like humidity. Yeah. So, yeah. 2 stress, 2 environmental conditions. Yeah. Yeah, constant stress condition. Yeah. So each location here is 1 testing condition. Okay, constant stress. And all those curves, they are the contour plot of the variability of prediction. Okay. So we also can use these 2 to, for example, make a comparison of 2 test plan. If you already have a test plan and want to compare with optimum test plan, and we can use these 2 to make a comparison. So that's yeah, that's right. Okay, so so if you are interested in, and we're really interested in to see if, how they could be applied in industry. So, pardon me? It's not Bayesian. It's not Bayesian. Actually, we can do sensitivity analysis, and also, for example, if you have your model parameter uncertain, okay, we can sample that and make a robust test plan. Okay. Yeah. Okay, that's my presentation. And finally, I thank you for coming here. And one logistic. Okay, if you park underground garage, I have the ticket and can help you pay it. So don't forget it. One sticker for an hour. So sure.